Okay, so today I'm going to talk about the workshop today is about like how to exploit the payday anomaly. Uh like feel free to unmute yourself like whenever you have a question or you have something to say. Feel free to just like unmute yourself or like type in chat. Uh for whatever you want to say or ask. I want to try to be I accidentally made that C#. I want it in Python. Okay, so do you have like an idea? So we only have one person today for this the live workshop. So do you have like an idea what the payday anomaly is? Like, do you have a
No,
guess?
I have like no clue what that is.
Okay, so like it has something to do with people getting paid. Like the day something happens on the day people get paid. Like it has some Okay, so what it is it basically like on certain days the stock price like generally goes up like abnormally higher than usual because the payday happens and usually companies allow you to buy stock at a discount, like they subsidize your purchase of stock, right? Like when you get paid, and so that drives up the stock price, right? Because there's an increase in demand. Hopefully that makes sense. Does it make sense?
Yeah, that makes sense. That makes a lot of sense.
Yeah, it's pretty simple. I think this is the like other than the simple moving average one, this is like one of the easiest ones. Okay, so let's just like the SPY 500 company, like the S&P 500. There's 500 companies, and according to academic research, it is like on the like 15th to like 15th to 16th day, like it's like I think they get paid like somewhere around like like midway through the month. And so like you want to buy on the 15th or buy on the open of the 16th and hold until like close. And that's basically the strategy. It's super simple. We can like talk about I'm gonna talk about how to like statistically like verify this anomaly. Okay, so what I'm gonna do is so I like subscribe to Pay Data, which is like the ETF that tracks the S&P 500. I'm gonna set the portfolio construction to like. Okay, so I'm gonna use the algorithm framework of Quant Connect, and it's basically like up to 6 components that you can use. And so equal weighting portfolio construction means that like you distribute the assets equally to each security. Actually, yeah, let's just leave that for later. Let's just use schedule events. So schedule events allow you to wait, no, never mind. Okay, never mind. Yeah, let me just do this. Okay, so self-taught portfolio. If not, self-taught so what this basically means is that like I'm not invested in anything in my current portfolio. And self-taught time. This time is a Python datetime object. So if self-taught time.day equal 15, I'm gonna set 100% of my cash to SPY. Else, I'm gonna liquidate SPY. Okay, let's issue. Let's just test. I think Okay, everyone. I'm going to teach you guys how to exploit the payday anomaly. And the payday anomaly is basically where you, like, on a certain day of the month, people get paid, and usually companies subsidize for employees to buy stock in the company that they work for. And so what that does is it increases the demand of the stock, and you basically buy it increases the price. So what you want to do is buy before that day. And so what you have to do is you shoot, don't look at that. Okay, yeah, let me just create a new one. So you subscribe. So what we're gonna do is do this on SPY. It contains 500 large companies, and it like SPY like tracks the S&P 500 index. So let's just do daily. Okay, so let's just check. If not self-doubt portfolio investing. So what that basically means is that like we're not invested in anything, like not invested in any equities, bonds, or just not anything. And self-dot time dot self-dot time. This time is a Python date time objects, and so we want to look at the date equals 15. We want to self-dot set holdings 100. We want to set 100% of our holdings to phi. Else we want to liquid. And let's test this for 5 years. Let's see how this does. Okay, so I think this is free strategy. I'm pretty sure this is free strategy. We actually have it. Okay, let's see how this. Like sometimes, like strategies just can be this simple, right? Usually strategies, like sometimes people like use some crazy neural network, and like I've tried using neural networks to trade. Usually they don't work because I use implementations from like a paper, and usually they just don't make money. So they're not very good. Oh, so let's see how it does. 1.364. That's pretty good sharp. Like usually like anything above 1 is usually pretty good. It's not bad. Like our compounding. I usually like to look for like a compounding annual growth return over drawdown, like ratio of 1, and this is like 1.8 ratio. Okay, let's keep track of this sharp. Let's 1.364. Let's see how like. So usually people want to look at risk-adjusted returns because, like, say you do something like super. Let me just draw this out. Like, so here's a graph. This is time, and this is like the dollar value of your portfolio, right? So you usually want something that looks like this. Like, you can have something that can make more return. It's just a T. But if it's like super risky, like this, like it ends up here, right? Up here, it's like you have a better compound annual growth return. However, you have so much risk. What happens if you like buy here, right? Or like buy here. Like here, you can like it doesn't really matter where you buy. It's usually a good entry, but for something like a portfolio value like this, like you can have higher return, but you still might not want it because of the high risk. And that is why we usually use sharp or sharp ratio, which is like the returns. Like usually it's excess returns above the risk-free rate, but the risk-free rate is basically 0 now. So people usually just round it to 0. just take the returns. So like say you make 10% per year, and then you take the standard deviation of the portfolio values over time. So like here's the portfolio value, here's the portfolio value. So we do is you take the standard deviation of that, and you take the returns and divide it by the standard deviation, and that's how you get Sharpe. So we get a Sharpe of 1.364. Okay, let's see how buy and holding buy does. Like I think we get a better compound annual growth return, but our Sharpe isn't as high. So the reason risk-adjusted returns are important is because, like, when you have, the reason having like accounting for risk is important because like what you can do is you can usually scale up or down your position using leverage or just like not allocating all of your portfolio. And so you want a good risk to reward ratio because you can just scale that up and down. Like you can increase the amount of risk for every unit of additional reward you want. You only have to take on an additional unit of risk. And you want the lower risk to, you want a higher, no, risk. I don't know. You want a higher reward relative to risk. Okay, so we can see the Sharpe ratio is 0.7. You can see that Sharpe ratio is lower. Okay, so how can we statistically verify this phenomenon? Let's do that. Okay, so we have a complex object. What a complex object basically is it allows you to like pull data. It's like complex is like specific to Quant Connect. And how do we get, okay, so let's just get data. History. Shoot. I didn't get the symbol object. Symbol. Okay, let's just do 500 days of data and resolution.daily. So we want, like, if we did minute data, we can also get minute data or second or like even tick. I think we can get tick data or hour. Well, here today we want daily data. Okay, let's look at what this data looks like. We only care about the close, so let's just data equals called dia. Just change the name. Equals data close. Oh wait, we have a multi-index here. What a multi-index is basically is like you have to first access by this index and the second index. So let's just to get rid of that. We only have one thing anymore. So dot loc symbol. So let's see what that data looks like. Now we got rid of that, and then now we only want closed data. Let's see what it looks like now. Okay, let's filter it again. Let's just look at the first 20 days of each month. Okay. It's called df2. df. And I'm going to show you how to, I'm going to show you like hidden wisdom. So pandas, like, this hidden wisdom. Okay, let's see. Pandas filter by index value. No Stack Overflow. Dot index. Here, let me just test something out. Okay, df.index 0 dot day. Does that work? Okay, yeah. df2 equals so what we want to do is get the index value like where the day is less than 20. I mean like less than your it's 1 to 20. We want the days of 1 to 20. Okay, I think it worked. Oh yeah, it did work. We can see here there's 29. We don't see that 20. Oops. We want it to be okay, yeah, that's right. Yeah, we get rid of all these dates because they're greater than 20. Okay, so let's df3 equals df2 dot returns pct, and to get the returns in pandas, you just do pct change, and let's see what df3 looks like now. Let's plot it. Okay, yeah, we can't really see anything from that. Okay, okay, so what we want to now is do is df.groupby, df3.groupby. Okay, pandas group by day of month. Is it? Oh, dang it. I'm just gonna make a new column. Sorry about that. Okay. So what I'm gonna do is introduce a new column. Shit. I thought this would be easier to do. Okay, let me just reset that df3. Okay, so we're gonna reset the index and df3 time day equals df3 time dot dt dot day. Sorry, I'm doing this live just to show how to do this process, but yeah, let's make this into a data frame. Maybe that'll make it easier. Oh, much better. What? Oh shoot. Does it work? Hey, let's get it. Okay, let's df4 equals df3 dot drop time. Oh yeah, we want to do a comma, so let's just x is equal 1 df4. That is what we want. Okay, let's. Okay, df5 equals df4 dot group by day dot mean. Let's look at df5, and we have achieved what we wanted to do. And let's plot this as histogram. Import matplotlib iplot as plt plt.hist df5. Oh shoot. Windows bar chart. F5 dot plots dot bar. Let's see on the 16th. Interesting. Let's look at the 1st first. Seems okay. Maybe if we use more data. Let's use more data. Let's use like 5 years worth of data, so that would be like times 252. I could have just do this. I could have just did run all cells. Seems a little more apparent now. It's like in the paper also said the first day was pretty statistically significant. Okay, let's see how we can convert this into like the algorithm framework. Okay, so we only have one security, but we need this to execute. And what this basically does is allocates equal amount to each security that we buy. And I think that's all we need. Okay, so if self.time.day equals 16, 15, we want to create an insight. So our insight is equal to insight.price. So there's different types of insight. Like, I'm pretty sure the only other one is insight.volatility. Honestly, it doesn't really matter what kind of insight you use most of the time. I always use insight.price. I never use anything else. SPY. Okay, so how long do we want to last? So we did it with 1 day. So let's just do days equal 1. And we want to specify the direction, so the direction. So we're gonna think it's gonna go up. So let's just self.insights. And since it's insights, it expects the list of insights. We're gonna just pass it in. Let's try this out. That's pretty good. I think it's the same thing. We also noticed that from there. Shoot, let's open that up. It seemed like the day before the first. So to capture that effect, we actually need to. So since the gains happen on the first, what we need to do is buy the day before the first. So, oh yeah, and the reason this happens is because usually paychecks are like bi-weekly, and there's another anomaly where like most of the gains of a stock is usually in the first 5 days. You can see here that lots of movement in the first 5 days. Third. You know, I'm gonna test something out. What happens if we like shorted? I haven't tested this yet. What happens if we shorted on the second day so we can capture the negative gains on the third day? Or self.time.day. So let's do the 11th. This is so what this does is it offsets the date time to the last day of the month. So the B month on import B month. Let's see in action the collab. Okay, let's roll for today's day. So from date time import date time dot now, which and from this we probably expect it to be on the 30th. Let's see. And we can see here it is the 30th. And so what we've done to do is check if it here. Nervous. Let's just copy this. Or self.time day equal. So this basically just checks if we roll forward if the date we are on currently is the end date. Yeah, let's just test this out down here. Oops. First, second, and you can see, despite it is just like it doesn't really do anything. It's pretty interesting. Okay, let's get rid of this. Let's see if we can increase our Sharp with this. So we got a 1.36 something, 1.364 for our Sharp earlier. Let's see if we can do better. Okay. Our Sharp we actually don't do better. Our return actually increases though. However, drawdown also increases more by the amount are pretty interesting. Okay, that's all I have for today. I hope you guys enjoy this, and please make sure that I just ask any questions in the comments, or just like message me personally. Okay, I hope you guys all have a great day. Okay, bye.